Hello and welcome to topic 1 for DCG, which is geometric principles. In this first video, we'll explore the first 3 geometric principles for this topic. So these include the true length of a line, parallel lines, and a line being parallel to a plane. So we'll begin by looking at the true length of a line. In order to give context for this, I've just given some examples to set the tone. So the first is in relation to a building facade. When you look directly at the front of a building, all of the vertical lines, the edges of the windows, the doors, the corners, they appear in their true length. And if we take another example of a railroad track, when viewed from the side, the parallel tracks appear as their true length, converging only due to perspective in the distance. So, just to include a sketch or to draw something that relates to this concept, the true length of a line is seen when we look directly at it. So for example, if I'm standing in position A, there's a line directly in front of me, and my point of view is perpendicular to that line. I am then seeing that line as its true length. If my position was to change for any reason, so if I was to go, let's say, to the right hand side, and again look at the same line, but at this time from a slightly skewed angle, the perceived length of that line from my point of view has now foreshortened, and my line of vision does not represent the true length of that line. So the most important aspect of this particular principle is that in order to view the length of a line as its true length, you need to look perpendicular to it. So the next geometric principle that we look at is in relation to parallel lines. Again, just to give some context, we've given examples which relate to this concept. So the first is in relation to road markings. The painted lines on a road remain parallel in every view. So whether seen above from a map or from a driver's perspective, the lines remain parallel. Window grids are also a very practical example of this concept. So the horizontal and vertical bars of a window frame remain parallel no matter how you view the window. So once again, using the same concept, if we use, let's say, for example, a Rubik's Cube, which would generally, on any of its faces, have 9 tiles. So there are lines that run horizontally parallel to each other, and there are lines that run vertically parallel to each other. And again, if we were to look at this from any angle, as the principle states, so whether it be from an acute angle from the left or the right, or from a relatively straight-on perpendicular view, those lines will remain to appear parallel to one another. So we can see the vertical lines remain parallel and the horizontal lines remain parallel, regardless of my orientation to them. And the third geometric concept that we'll explore in this first lesson is that lines are parallel to the plane on which they rest. So again, some practical examples of this. If we were to think of a skyscraper and the cloud moving horizontally across the sky is parallel to the vertical face of the skyscraper. The picture frame on the wall is one of the more simplistic examples. So if you were to take a picture frame and look at the top edge of it, hanging flat against the wall, it is parallel to the wall's surface. So essentially in DCG, we'll often be presented with an oblique plane or an inclined plane, like so. And there may be a number of lines that are present on that plane. It's important to note that all of those lines remain on the plane, and therefore whatever direction or orientation that plane has, the lines have the same orientation, so they remain parallel to the plane in which they are resting.
If you like this video, you'll love our notes. You can get some for free in the link in the description of this video.